Hello and welcome to Career Making Classes. So, in this session, we are going to learn about carbon and its compounds. So, we have 118 elements, right? And carbon is also one of them. Then, why it is so special that we are devoting one chapter on it? Actually, carbon is so interesting and it has versatile nature. For example, let's see these two pictures. One is of graphite and one is of diamond. Graphite and diamond has no similarity. Of course, they look different. They have properties different. But still, one similarity is there, which can blow your mind. It is that both are made up of carbon. Wow, yes, that they both are made up of carbon. Let me give you one more example. It is of coal. Yes, coal is also made up of carbon. It is made up. It is used as fuels, right? So it is also made up of carbon. So now you get to know why we are studying that, right? Carbon is so special. Carbon is so special. So I hope I have generated some interest in you. Okay. So in this chapter, we are going to learn about properties of carbon and the compounds made up of carbon. Okay, so this graphite and diamond is also compounds of carbon, right? So one more question arises, like how carbon attaches and make compounds, right? Actually, they make bonds. Like when they attach with themselves, they make bonds, right? They make bonds, hence they are combined to form any compound, right? So what are the bonds? Are there different types of bonds or they're single which carbon makes? No, let us discuss that. So before getting ahead of compounds, we have to learn bonds, right? How they are combining. Exactly. So types of bonds. There are two types of bonds, right? First is ionic bond and second is covalent bond. As usual, heavy names but easy meaning. Okay, so ionic bonds. So what is ionic bonds, right? It is of like it is so simple. When a metal and a non-metal combines, they combine with ionic bonds, right? And what is covalent bond? When a non-metal and a non-metal combines, they form covalent bonds. Is that it? Yes, it's so simple. It's nothing like heavy philosophy. It's so simple. Ionic means a metal and a non-metal. They combine to form ionic. Right? What is covalent? A non-metal and a non-metal. They combine to form covalent bonds. Right? So how they do that? Ionic bonds are performed by the transfer of electrons. Transfer of electrons. How? Okay, let me give you an example. Like you are hungry, it's lunchtime, you are hungry, your friend is also hungry. Okay, you open your tiffin and you are hungry of two chapatis, your friend is also hungry of two chapatis, but you have four chapatis in your tiffin and your friend forgot tiffin in his house or something, right? So you ate two chapatis and you give two chapatis to your friend. Okay, simple. That was the transfer of chapatis. So here we do transfer of electrons. If we are transferring your electrons, one element is transferring their electrons to other elements, they will form ionic bonds. Like one has access and one lacks, so they transfer, right? So if someone is transferring their electrons, they are called ions, right? So ions are combining, hence the name suggests ionic bonds. Okay, so what is covalent bond then? If it is transferring, we have learned in school that it is sharing. No, in science terms it is transferring. Then what is sharing? And is there any use of sharing in this topic? Yes, because covalent bonds are formed by sharing of electrons. How sharing then? Okay, wait. Let me give you one more example. You and your friend went to the shopping. You found a beautiful necklace, gold necklace. But After watching the price tag, you both are your both faces got pale. The price was too high. You individually can't afford that. But if you contribute money, if you both give your shares, then you can afford that. Yes, you can afford. So in this case, what will you do? Your both friends will give money, they collect money and bought one necklace, and they will use that necklace on alternative functions, right? So what will you do? They're doing sharing, like no one is the individual owner of that necklace, both are sharing that, both have same contributions, so both are sharing that. So that's what we called a covalent bond. In covalent bond, no one has individuality. Okay, no one is the owner, they are just sharing the electrons. Okay, like the friends are sharing necklaces, so here elements are sharing their electrons, and specifically non-metals are sharing their electrons. Okay, so one more thing, high melting point. Okay, wait, nothing to memorize, just I'll give you just an example. By example you can clarify everything. Okay, so high melting point. Okay, let me tell you one thing. Let us come to that example. You are hungry, your friend is also hungry, you ate two chapatis and you give two chapatis to your friend, that's it. Okay, is there any chance of dispute? No, both's belly are full, right? Both are satisfied, no one is like, no chance of dispute is there. So their bond will be strong, right? Their bond will be strong. But in case of that necklace, if the function arises at same time of both the friends and were demanding of the same necklace, there are high chances of dispute, right? Because the contribution was same, and both will prefer their individuality, so there are high chances of dispute. So covalent bonds are weak bonds and ionic bonds are strong bonds. I hope this concept is clear. Then what is high melting point? Is that ionic bonds are so strong that we need high temperature to melt them. That's it. So for covalent bonds, we need low temperature to melt them, and the temperature at which a substance melts is called melting point, right? So, okay. Wait. Nothing to bother about these words. Okay, let's take one more example. Okay, explanation especially. Electrons are transferring from one object to another. Electrons are transferring from one object to another. Electrons are transferring from one object to another. You will think, are you got mad? Why are you repeating your words? Actually, I'm making your mind sharp. Actually, what what the transfer of electrons signifies? The movement of current, right? The movement of current, right? If a substance conduct current, if a substance allows the electrons to pass through them, if a substance allows current to pass through them, and what is the substance called? Conductor, a good conductor. So ionic bonds are good conductors of electricity. So in case of covalent bonds, because no electron is transferring, they both have that, so nothing has transferred, they just shared. So it will be a poor conductor of electricity. So simple, so simple, right? So this was it of two bonds, ionic bonds and covalent bonds. That's it, nothing to learn more about that. This is more than sufficient. Okay, so why we have studied that? Okay, we have studied this topic. Okay, then what is the significance of this topic? Actually, we have studied because carbon and its compounds, as the name suggests, carbon. So is there any relation with carbon and this topic? Of course it has. We have covalent bonds, right? Non-metals and non-metals. Yes, carbon shows covalent bonds. So carbon shows covalent bonds, and this chapter is of carbon. Then this suggests that in this whole chapter we are going to learn about covalent bonds, especially made by carbons. So nothing to bother. We are not studying more about ionic bonds. So take it as a side, but have knowledge of that. That what are ionic bonds? Transfer of electrons. They have high melting point, and they are good conductors of electricity. Right? What about covalent bonds? Like they have sharing of electrons, right? They have low melting point, and they are poor conductors of electricity. So that's it for this topic, types of bonds. Then what is the another bond then? What is the another topic then? Electron dot structure. Electron dot structure. What is it? This name is like out of our mind. What is this? Actually, mark my words, this is the most important topic of this chapter. One of the most important topic. Like I could say that the question will arise from this topic in your exams. Definitely. This is the favorite topic, and this is so interesting. It is so conceptual. We don't have to memorize. We have to understand the concepts in it. So it is very interesting, and it is very important for exam, right? Electron dot structure. Okay, as the name suggests, we are going to deal with electrons. Then what is dot? Dot means we are representing elements, representing electrons by dots, or we can use cross as well. Okay, so there is nothing about cross in the heading, but yeah, we are dealing with cross mainly. So this was irony. Okay, so let us discuss about the molecule of hydrogen. Okay, so we are studying about carbon, then why molecule of hydrogen? Wait, let me tell you, carbon will attach to carbon, right? But some bonds are empty for carbon. Then they are attaching with, most of the time the carbon is attaching with hydrogen. Most of the time, yes, most of the time. More than carbon is attaching with carbon, it is attaching with hydrogen. If two carbons are attaching, then there is high chance then that 6 hydrogen are attaching with that 2 carbons. So it is important, right? It is important to learn about hydrogen. So the molecule of hydrogen, right? Let us draw a dot structure. Means how molecules of hydrogen attaches. Like we always heard of H2, right? Never we have heard of H. Then why the 2? But that means that 2 atoms of hydrogen are combining. By which bond? Covalent bond. Yes. Covalent bond. Why covalent bond? Because both are non-metals. Non-metals are attaching and hence making covalent bond, right? So two hydrogens are attaching and making covalent bond. Let us discuss about their electron dot structure. So here we have the electron dot structure. I know this looks so complicated, so scientific, but nothing to worry about. This is not a rocket science. It's so easy. Okay, we have two atoms, one hydrogen and one hydrogen. Okay, so what is that cross signifies? Actually, as I said, it is irony that it is electron dot structure and we are using cross. You can be use cross and dot as well. Okay, so it's all upon you. Dot is also correct and cross is also correct, right? But use only one, right? So cross, what that cross signifies? Electron. Like hydrogen have only one electron. We have studied it in 9th class, right? Hydrogen have only one electron. So in this shell, it contains it should contain 2 electrons to maintain its stability. Of course, it should contain 2 electrons to maintain its stability, but it only have one. Then it signifies that it needs 1 electron, right? And if it want to make a covalent bond, then it needs another non-metal, right? So if it is attaching with hydrogen and hydrogen, both have one electron, the transfer of electrons can't be possible. Why? If one hydrogen transfer it's one electron, then this hydrogen have nothing, then it will not exist, right? So they do sharing of electrons, they both share their one electron, hence has one hydrogen have two electrons and one hydrogen have two electrons, hence they maintain their stability. So we never find hydrogen as individual, it always find in a combined form as H2, it always find in a combined form. So that's the reason why it is always fine, right? One electron they are sharing, hence they are making up two electrons, right? Single bond formation. Why single bond? Single bond means one electron, hence bond, right? Hence bond. Okay. Hydrogen one electron bond. Okay, clear. Okay, so if you haven't clear yet, we have so much examples of that, so nothing to get worry about. Another is electron dot structure. There is one more example we are discussing, not one more, we have lots of examples for discussion. It is the molecule of oxygen. Of course oxygen is also a non-metal, then it can attach with oxygen, right? We always found O2. Why we do not found O? No, we always found O2 or O3 in a combined form, right? We never found one O. We never found the individual oxygen. Then what is the reason behind that? This is the reason, because every element makes its compound to maintain its stability, right? To which stability? Near its noble gas configuration, right? What is this? We're gonna learn it later. Yeah, we gonna learn this point later in detail, right? So let us come to the topic, the molecule of oxygen. So this is the oxygen, one oxygen. So okay, tell me, how many electrons are there in the last shell of oxygen? It's 6, right? Oxygen comes on 8th place, so 2,6. So last shell is of 6 electrons, right? Oxygen another is also of 6, they are same atoms. If they are combining, they lack only 2 atoms, right? So what will they do? They will share their two electrons. They can't transfer. No, they can't transfer. They will share their two electrons, right? Like 1 2 1 2. So they will share their two electrons and it will form double bond, right? So what we say, what is two electron? It's two pairs, right? Bond means pairs, how many pairs of electron is being shared, that's called bond. Like single bond means one pair of electron, means two electrons, right? And in molecule of oxygen, double bond formation means two pairs of electron are being shared. Two pairs of electron means four electrons, right? I hope this topic is now crystal clear to you, right? If still not, then let's take one more example. We have no like condition for example. Let's come to another. Electron dot structure. The molecule of nitrogen. Okay, nitrogen is also a non-metal, right? It can form covalent bonds. So if you found that any metal is forming covalent bond, right? So that metal is not a metal, that is non-metal. I've already discussed that metals can't form covalent bond. So if someone is saying metal is forming a covalent bond, then get out of that place. That person is not mentally stable, because metal can't form covalent bonds. Yes, there is no exception of it. Metals can't form covalent bonds. Yes, so another example, let's come to another example. The molecule of nitrogen. So the molecule of nitrogen, okay, so let us recall how many electrons are there in the last shell of nitrogen? Right, 5 electrons, right? So 5 electrons in their last shell, right? So how can they share? They need 3 more electrons, right? They can't donate, they can't take, right? If they are both non-metals, they can't transfer their electrons, so they are sharing. So how can they share? They need three electrons, right? 3 from this side, 3 from this side. They can, what they can make? They can make covalent bond by sharing of 3 electrons. Mean 3 electrons means 3 pairs of electrons, and 3 pairs of electrons means triple bond. Yes, triple bond formation means we are donating this by 1 2 3. 3 lines means triple bond. Single line means single bond, and double line means double bond, right? And what this lines, one line signifies, it signifies a pair, a pair. Okay, so that's it for electron dot structure. If you haven't get my words, then please rewind my video and you will get what I want to explain you. And please mark my words that this is the one of the important topic of this chapter. Yes, it has high weightage in exams. So another topic is allotropes of carbon. Oh my god, another one heavy name. Another heavy name, allotropes. Heavy name meaning easy. Yes, heavy name contains easy meaning, right? So allotropes, what is allotropes? Actually, allotropes means compounds. Yes. So why we are using that such names? Because we have made carbon so special. Like it doesn't satisfy with the word compounds. It says I make that much big compounds. So I need special name. So he signifies allotropes. So that will be the special name of my compounds. So there is a there we can say there is an attitude in carbon because he is so special. Yes, so allotropes of carbon. So in this video we are discussing about 3 allotropes of carbon which are too important for your exam point of view. Okay, so first one is the structure of diamond. First allotrope is diamond, as we have discussed in the first slide, right? In the first slide, what is the diamond and graphite? So first one is the structure of diamond. Okay, then the structure of graphite, we are learning them parallelly, so nothing to worry about. We are learning them parallelly. So this is the structure of diamond and this is the structure of graphite. Oh my god, what is this? Is that diamond which shines, which attract ladies? Is that diamond? And what is the graphite? It is like a net, of course. Yes, the compounds the carbon forms net-like structure and hence results in its compounds. No, compounds. No compounds. You will get angry. Use the word allotropes. Okay, so you use the word allotropes exactly, and it will form carbon will form net-like structure. Okay, if one carbon, then what are the conditions it make diamond and it make graphite? So let me tell you, if carbon is attaching with 4 carbons, right? If every carbon is attaching with 4 carbons and making up branches and making chains, it is called diamond. It will form diamond, as you can see in this picture in the net-like structure. What it suggests is one carbon. Yes, that ball suggests carbon. Okay, rather than writing C, we have represented it by one ball. Okay, so one ball, and this one line suggests that bond. Which bond? Covalent bond. Okay, so carbon is attaching with 4 carbon, every carbon. So you see that last carbons are not attaching. Actually they are also attaching, but we have not signified the long chain. We have taken a short part of that net, right? What we are signifying, the net, the short part of a net. So one carbon is attaching with four carbons. If one carbon is attaching with four carbons, then and it makes branches, long branches, it alternatively it will form diamond, the structure of a diamond. Yes. What if it is attached with three carbons and one is attached with, like, one is double bond and all the carbon is attached with three carbons? It can also happen, right? It can also happen. Then what will form? It will form graphite, right? If carbon is attaching with three carbons, one carbon is attaching with three carbon and forming long chains and branches, it will form graphite. If carbon is attaching with four carbons and forming long chains, right, it will form diamonds. One more thing, the diamond is like, the diamond has no double bonds. Why? Because carbon can make four bonds only, right? And it is making with all carbon, so there's only single bonds, right? There's no double bond in diamond, and there is double bonds. There are double bonds in graphite. Yes, there are. So because carbon can make four bonds and it is making three bonds with individually carbons, right? Then what about the fourth one? It is forming two bonds with one carbon, like that. So graphite contains double bonds. Okay, graphite contains double bond. As you can see, diamond is forming a three-dimensional structure and it is forming a net-like structure. But there is something special about graphite. As we look at its structure, it's like, what is this? This shape is familiar for us, as we have learned in maths, right? It's a hexagon, right? Six sides, hexagon. Okay, hex means six, right? It is of six sides, means hexagon. And yes, the graphite is made up of the carbon made hexagons, right? It and forming a net-like structure, yeah, and forming long branched chains. So it is the structure of graphite, and this is the structure of diamond. Okay. So one more thing, diamond, we have already discussed this topic, like diamond is the hardest substance. Like the substance which is too hard, we use diamond to cut that. Yes, diamond is used to cut that hardest substance. So hardest substance is cut by diamond. So what is hard? Who is hard now? Diamond is hard, right? So diamond is too hard. It is the hardest substance, and yeah, it is hard. So graphite is so smooth. Yes, as you can see the pencil lead, right? It is so smooth and it is slippery, right? That's why it is used as solid grease in machines, because it is slippery, right? Sometimes liquid grease is not used, like it can affect the machines. So solid grease is used, and we use solid grease as graphite, right? So that's it for graphite, and that's it for diamonds. So let's end the class. No, there is one more allotrop we have to discuss. We have promised you to learn, to teach you. Yes, we have promised you to teach you three allotropes of carbon. We have done two, diamond and graphite, right? What is the third one? The third one is fullerenes. I have never heard of that. I'm sure you too. But okay, we will discuss it together. Okay, so it's a new concept, right? Okay, so look at the structure of fullerenes. It is made up of lots of pentagons, right? You can see 5 sides, pentagons. Yeah, it is called fullerenes, and what we can also conclude from its structure is that it is like a football. Yes, it is like a football. So it has football shape. So what can we also conclude from this shape? Okay, so nothing to conclude yet. It's of pentagon and It's a football shape. It is made up of carbon 60, right? 60 carbons are joined together to form a fullerene. Okay. So, and what we can read in the picture is that the structure of C60 Buckminster fullerene. What is this? Again, let's read again. Buckminster fullerene. Firstly, we haven't heard about fullerenes, and what is this Buckminster? Okay, let me tell you. It's a scientist. Okay. It is a US architect. Okay, it's a US architect who have designed a fullerene. Like, it's his name was Buckminster Fuller. Buckminster Fuller. So, in the honor of his name, the substance is called fullerene. In the honor of his name, the substance is called Buckminster fullerene. So, Buckminster Fuller was his name. He was a US architect. He designed the shape of a fullerene and also a football shape. Maybe he was fond of footballs. Maybe he liked the football. Okay. So that was it for the allotropes of carbon. That's it for this lecture. This was the first part. We have divided this chapter especially in many parts. This was the first part. In next part we I promise. Okay. In next part I promise you to teach the versatile nature of carbon, because we know carbon is so interesting. So it takes time to learn complete about carbons. And yeah, especially even scientists haven't learned complete about him, but we can have some introduction about him, right? So I hope you have generated some interest in this chapter, and you will be waiting for the another part of this video. And if you have some queries and some suggestions, you can write down in comment section, and I will try my maximum to answer these questions, right? Okay, one more thing, that what we have discussed in this whole lecture. First, we have discussed about the nature of carbon, why carbon is so special, how it can form bonds, right? How it can form bonds and form compounds. Then we have discussed the types of compounds, right? There are two types of compounds, ionic compounds and covalent compounds. We have discussed what is ionic compound and what is covalent compound. Then we have discussed some important thing, some very important thing, not some very important thing. It is electron dot structure, right? Electron dot structure of oxygen, electron dot structure of hydrogen, and electron dot structure of nitrogen. Yes. Then we have discussed about allotropes of carbon, which was allotropes of carbon, which was diamond, graphite, and fullerene. So that's it for this lecture. Stay tuned, be happy. Thank you so much.